Hi, I am Mohammad Nadeem from Exam Help Web. In this video, I am going to describe fundamental concept of electromagnetic induction. Electric current and magnet behave alike in some ways, especially when we study the area of influence of electric current and bar magnet. This idea was first presented by a scientist, Hans Christian Ørsted. In order to understand this relationship, connect a long straight wire with a battery and allow the current to flow through it. Bring a magnetic needle near the conducting wire. The magnetic needle will align itself along the field lines. These field lines show that the conducting wire develop a magnetic field around it. The lines near the wire are strong. It means the magnetic field has more strength near the wire, and as we move away from the wire, the magnetic lines become weaker. It means that when electric current flow from a conductor, it behaves like a magnet. Now place a bar magnet on a piece of plain paper and draw magnetic lines of force with the help of magnetic needle. And we find a strong magnetic field near the poles, and as we move away, the magnetic lines or strength of magnet become weaker. Now in place of a straight wire, if we create a loop of wire, which is usually called a solenoid, and connect this solenoid with a battery, we find the similar shape of magnetic field that we see in the bar magnet. Now we know that flow of electric current through a magnet generate a magnetic field. But is it possible to reverse this process and generate electricity from magnet? This idea was first tested by a scientist, Michael Faraday. He invented the first electric motor, and he continued his research to show how the electric effect can be reversed to generate electricity. In his first experiment, he connected a galvanometer with a solenoid and placed a bar magnet near the solenoid. In this situation, he did not find anything because there was no deflection of galvanometer needle. No current was induced in the solenoid. He continued his research and reached to a stage where when he moved the bar magnet towards the solenoid, and he noticed the galvanometer needle deflection, and that was the sign that the current was induced in the solenoid. He continued the movement, and in the next phase he moved the bar magnet away from the solenoid, and he noticed that there was again a deflection, but in the opposite direction. So in both the cases, when he moved the bar magnet towards the solenoid, the galvanometer needle moved towards the bar magnet, but when he moved away the bar magnet from the solenoid, the deflection in the galvanometer needle was against the movement. So it means that there was induced current, but the flow of current was in the opposite direction. He tested the same experiment by reversing the poles of the magnet, and he noted the same effect. When he moved the bar magnet towards the solenoid, there was induced EMF in the circuit, and when he moved away the bar magnet, there was induced current in the solenoid. He repeated the experiment alternatively by fixing the position of bar magnet, and he moved the solenoid towards and away from the bar magnet, and he noted the same deflection in the needles. So it means that he reached to a conclusion that electromagnetic induction is the process of generating electricity by relative movement of bar magnet or a solenoid. And he further investigated and stated that induced current can be increased by three different ways: by increasing the number of turns in the solenoid, by moving the bar magnet or the solenoid rapidly, or using a strong bar magnet.